Okay, I've had some sleep. I'm still waking up actually. Yeah, I've got it running at the moment, and it's not doing so bad really. But one of the problems that I've got with it is my magnetic gate trap, which isn't isolating properly. That's probably because I'm using ferrite cores. Because my original design, well, these are the ferrite cores basically. There's a ferrite core between each concentric arrangement, and so the problem really is the fact that there's the magnetic trap to prevent a lens effect coming back is not 100% efficient. Well, it's working partially, but not enough. And my original design, I was using steel laminations, so that I could basically switch the flux. Now, what I was thinking of doing, the original design, obviously, I had too much steel. The steel was too long, so the losses were huge. But I've got these smaller pieces. These are smaller pieces which I could incorporate, because if you look at the actual dimensions, they will fit perfectly, actually, apart from the bits that stick out, which I could chop off, you know. But I've got a lot of these, so I could put these in and make a variation on the original design, which I did about 3 or 4 years ago, and have the ferrite cores after the trap, right? So the ferrite cores will still run all the way through the coil, you know, for the middle section that's there, but have these steel sections on the trap. So basically, when we subtract one flux field from this core on this side, which is one pole, the other pole will be allowed to do its thing. But the only problem with it is the fact that is looping back. Is the fact that some of the flux would loop back on itself. That's the problem I'm having, is the loop back effect, and so it might actually with the north and the south pole, it might work well. But when you've got another north and a south pole on the other side, it can loop back on itself. Hang on a minute, I'll show you what I mean. So when you've got two of them, and you've got one switching south on this side and one switching north on this side, there's a certain amount of bleed through between the two, and I've been testing this with washers, and I put a washer on the end, and basically it cancels itself out. So that is a problem, but I'm going to build that anyway and test it out and just find out. But at the moment, we're not doing so bad really. I mean, we haven't got a huge amount of drag, because this meter uses about 40-50 milliamps. I think I need to turn it off a minute so I can show you what's going on. But right, the meter is using. Hang on a sec. I'll pause a minute. Bugger it. I was trying to unclip this, but the clips are on here, and I don't want to disturb it. So, well, we just have to subtract about 40-50 milliamps. But at the moment, the motor's using about 100 milliamps, and power consumption, we have to subtract the meter amount, which is about 40-50 milliamps. So yeah, it's showing up as 170 milliamps. So that's what's been going into the motor. But this is what the scope reading is. Interestingly, I've got dual waveforms when I've got the coils in series. I seem to have double waveforms, which is really interesting. Superimposed waveforms. Now, I haven't seen that before. Yeah, very, very strange. Basically, my device appears to be putting out dual waveforms superimposed upon each other, because of the way I've got the coils wired in series. And obviously, the two of the coils on the outside, which are I haven't got this set of coils at the top connected either right now. So the top set is not even connected. I'm just using the bottom set right now. they're connected up, but they're not the top set. There's an alignment issue with the top set. I need to work that out as well. I haven't got it perpendicular. The azimuth isn't correct on the top set. The azimuth seems to be not bad on the bottom set, but it's the top set which it just isn't right. But basically, the outside coil, which is on the far right, and the other outside coil on the far left, they're very narrow coils. They're very thin, and on the bottom set, I've got them all wired in series with the two central coils. And because of that, I'm getting a dual waveform, which is really interesting, as I've just been showing you on the scope. We're at 625 RPM, and we're powering an LED array at the moment through a boost converter. So I've got this boost converter, which is stepping up the voltage from the bridge rectifier assembly, which so I'm just using one bridge rectifier at the moment through the coils which are all in series, and it's powering this booster device which I've set to 12 volts output, but we're not getting the full 12 volts because it's pulling it down a bit. So that's why we've got two banks of LEDs lit, but the other bank on the top isn't lit up. But yeah, we're short circuit current is around about 150 milliamps, so that's short circuit current. But anyway, yeah, so there's a few more tweaks I need to do. Well, it's as they say, inventors or flipping innovators or whatever you want to call people who like to develop and do research and development and all that stuff. It's a never-ending battle, really. It's a never-ending battle to solve a problem, really. I mean, I think Edison must have spent, I think, most of his life working on the light bulb or something, or many, many years working on the light bulb, trying out different types of filaments and things. So, I mean, it's to be expected. Not that we'll ever be as famous as him, but it's fun, isn't it? It's fun. So anyway, that's basically a little update on what I'm doing right now. So I'm going to go back to SketchUp and see about designing a new holder. The actual V formation is working very well, which I was mentioning about reducing drag. There's virtually no cogging on this whatsoever. When I turn it off, there's no cogging I can detect. Actually, I'll turn it off and we'll watch it spin down. Right, I've turned it off now, so RPM's gone out. There's virtually no cogging on it. There's a very small amount, which is good. Cogging is when it snaps to a certain area, when it slows down, but it's got very little cogging on it. Right, we're nearly stopped. As you can see, very little cogging. I mean, it didn't snap to any. It just snapped slightly, but if I turn it by hand with my fingers, just turn it a bit, you can see it's really well balanced. Just turning it, there's a slight amount of swing, but very little cogging there. Yeah, okay, thanks for watching.